It all begins with the Earth's most abundant raw materials. The primary ingredients are sand, lime and dolomite, soda and sulfate. Glass itself is also an important ingredient. Its recycling reduces the need for raw materials and accelerates the melting process. As a result, energy consumption is limited and less CO2, one of the main greenhouse gases, is emitted in the atmosphere. In addition to recycled glass, crushed or broken glass, called cullet, is added to the mixture. Cullet comes from both the manufacturing process and customers' scrap cuts. The mixture of raw materials used for melting is known as the batch. Its exact formulation varies whether transparent or colored glass is desired. The various raw materials are transported to the factory by truck or train and are stored in silos in the batch house. All these raw materials are rigorously checked to guarantee the purity of the batch. Each material is weighed by scale before being delivered automatically into the mixer. This is when recycled glass is added to the batch. Effective batch mixing is key to the melting process. Best glass quality can only be achieved when the batch has the necessary homogeneity. About 4 to 5 tons of the batch are conveyed around every 5 minutes to be distributed in the batch charger. During the process, a flat glass ribbon of uniform thickness is formed on a 500-meter-long line. The batch charger regularly lays down raw materials at the furnace entrance on a part of the line called the doghouse. The raw materials drop on the 1,300 degrees Celsius molten glass already contained in that area and are continuously pushed inside. In the melting zone, the batch of mixed raw materials melts at a temperature of 1,550 to 1,600 degrees Celsius until it becomes liquid and merges. Melting occurs by heat transfer from the flames located above the glass surface. Chemical reactions between the different elements allow the elaboration of high-quality glass free of bubbles. The process within the furnace is continually monitored by technicians who take measurements inside and from screens in the control room. The flames develop above the furnace. Every 20 minutes, their direction is reversed to optimize the thermal balance in the furnace and the efficiency of the flue gases heat recovery chambers. In the working end zone, to prepare the spreading of the glass over the tin bath, it is cooled down from 1,400 to 1,100 degrees Celsius. A cold airflow is regulated for it to precisely reach the temperature and viscosity required at the forming zone. Glass is then ready to leave the melting furnace and enter an enclosed bath of molten tin. At that point of the process, the glass looks like honey. At the beginning of the float bath, glass coming from the furnace flows gently and spreads out, literally floating on the molten tin, to become a continuous ribbon of perfect flatness. The edges of the glass puddle are mastered by top rolls machines, which act on the spread surface of the glass. The top rolls effect, together with the exit speed of the ribbon, are the two main factors to adjust its thickness and width. In order to optimize the production performances, these steps are monitored from the control room 24 hours a day, 7 days a week. At the end of the float bath, the glass is cooled down further and leaves the tin bath at around 600 degrees Celsius, when it is just solid enough to climb on metallic rollers and be driven inside the layer. In the layer zone, the glass is annealed and gradually cooled to relieve inner stresses and prevent splitting in the cutting phase. Cooled down too quickly, it would break. The layer measures from 150 to 200 meters long and is made of 2 parts. The first one is the annealing zone, where the temperature decreases from 600 to 480 degrees Celsius and where permanent stress is fixed. This is a critical part of the process to give the glass a cutting quality that matches customers' requirements. The second part of the layer is the cooling zone, where, depending on its thickness, the ribbon is gradually cooled to reach a temperature between 50 degrees Celsius and 80 degrees Celsius. At about 300 degrees Celsius, it becomes possible to lock out the downstream area of the line without impacting its upstream part. This can be useful for maintenance purposes, for instance. The operation, called water break, consists in sprinkling water on the surface of the ribbon to create a thermal shock effect that causes the glass to crack and break. Past the water break point, the layer is not covered anymore. The cold end is the last part of the production line. It includes quality control, cutting and stacking. The entire glass ribbon is continuously checked by a high-performance optical system to detect all kinds of defects. Thanks to the information received by the control system, an automaton maximizes the production of the ribbon with regard to the quality standards. Glass sheets are automatically created by a two-step cutting process in which the ribbon is striped and snapped along those strips to standard dimensions. The longitudinal stripes are made by a diamond wheel that creates surface defects on the glass. This prepares the ribbon for the subsequent cut of its edges, thereby removing the top roll marks and obtaining the net width. Then, the traversal stripes will determine the length of the glass plates. In the breakage area, the continuous ribbon is interrupted to form glass plates. The breakage operation consists in a lever effect made by an automatic breakout bar aligned with the transversal cutting line. Next, the edge rollers apply a pressure on the longitudinal cutting lines to trim the glass plates. The edges, together with any glass area not fulfilling the required quality standards, go back into the furnace for recycling. The plate thus formed is then carried by rolls at higher speed to separate it from the continuous ribbon. These final glass sheets are absolutely transparent and have perfectly smooth surfaces. They are ready to be automatically stacked as calibrated piles of glass, weighing from 2.5 to 20 tons. The glass piles are offloaded thanks to special handling machines called transloaders. The glass is then conveyed to the warehouse for storage or to the expedition area, ready to be sent to customers.